right, ladies and gentlemen, so we are going to continue on our discussion for Unit 2, the elements of art. And right now we're going to be talking about shape and form. So there's two of these that we're going over today. So let's begin. So right now, the 7 ones that we're going to be talking about: color, value, line, shape, form, texture, and space. We are focusing on shape and form. Now, shape, which we've already talked about briefly, is a two-dimensional enclosed space with its boundaries defined by the other elements of art. This sounds really complicated. It's really not. So let's talk first. We'll break this down by the bolded words. Let's talk first what two-dimensional is. Two-dimensional is width and height. Okay, so those are the two dimensions. And when it's defined, when the boundaries, the edges, are defined by the other elements, that means we're talking about a square that's red. And the only reason we can see it is because it's red. If it was white, as stated previously, we wouldn't see it. If this line wasn't here, we wouldn't see it. If you look at the walls of the school, you can tell where the shapes for the bricks are because the value changes. There are areas that are light and areas that are dark to give you that seeming for where the brick shapes are. Okay, that's what it means when it says that the edges are defined by the other elements. Shapes exist only because we see them, because there's other elements to point them out. So we have two different types when we're talking about shapes. We have geometric shapes and we have organic shapes. Geometric shapes are mathematical. That means that there's math equations. The length times height gives you the area of of a quadrilateral, really, well, of a square. Okay, length times height. Every square in the universe, 4 equal sides, 4 90-degree angles. Every circle, pi r squared, determines, the circumference. All of these things, actually, that might be, regardless, I haven't reviewed my formulas in a really long time. Regardless, there's math equations that define these shapes. There are names for these. Every circle follows the same rules. Every triangle has 3 sides with 3 angles that add up to 180 degrees. Okay, so these are rules. This is how they work. This is an example of mostly geometric shapes. There are some in here that would not be considered geometric. For example, this big giant bottom here, that's not a geometric shape. But the focal point, the place where you draw your attention, is geometric. It is absolutely a circle. Now, the tournesol is French. And as with many of the paintings that we've seen so far, artists are really good at naming their stuff. So it can be assumed that the tournesol is literally what this image is of. Now, this is abstracted. That means it's not very realistic. But if you look at it and you think about it, we might be able to guess what Le Tournesol means. So I want you guys to take a little bit and see if we can figure it out. Okay, we're going to move on. Freeform organic shapes are not defined by mathematics. They don't have math equations that define their area or their perimeter. There's not a set stone name. We can call this an ink splat. We can call it a paint splat. We can call it a schmear. We can call it an oil drip, whatever we want. And all of those kind of fit the description of what we see here. But do all of those things look exactly alike? Is every paint splat on the face of the planet and in the universe look the same? Do they follow the same rules? No. Okay. So they're irregular, and that makes them organic when it comes to art. All right. It's not organic in sciences, but in art it is. This is an example of a whole lot of organic shapes. Now, this is concept art by Mary Blair. This is from Alice in Wonderland way back in the day. And there's a lot of different organic shapes that make this up. Now, the image itself looks really complicated. But if you look closer, all of the components in this image are actually incredibly simple. We've got these sporks on a stick. They look like tulips though. And then we have like 3 or 4 little dots, dot, 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 on the image with an inside. That's it. These little dudes, they don't look anything alike. None of these flower faces look alike. Some of them look like octopuses, some of them don't. These are literally just circles. This whole grouping of flowers right here is just circles. These roses are pentagons with a spiral drawn inside of them. None of these are complicated, but because they are all put together and grouped like this, the image looks complicated because the colors were arranged on purpose, it looks complicated. All of you are capable of drawing something like this. You just have to learn how to break it down and make it simple. All right. Now, implied shapes are fun. They don't exist. But I bet every one of you can see that white triangle. It's not real. We can use them, though, these negative space images, we can use them to help draw this better. It is actually pretty difficult to draw those 3 red not quite circles and make them even. The reason that the triangle is there, if we actually start with a triangle and then draw circles around the corners and then erase the triangle out, it is much easier to accomplish this specific design. So we can use those negative spaces. We can use those implied shapes in order to create the image that we need. Now, this is the Pont du Gard Aqueduct. This is in France, built by the Romans, big giant thing, brings a lot of water. It's a marvel of engineering. It's pretty freaking cool, all things considered. But none of those little semicircles exist. They're not there. They're just empty space. But you can use those in order to better draw the aqueduct itself. By paying attention to those negative areas and those empty spaces, you can make it much easier to draw the actual aqueduct. Form. Form is a 3-dimensional object that encloses volume. It has height, it has width, and it has depth. So height and width, just like with the shape, but now it has depth, distance from the viewer. Okay, that's what makes it 3-dimensional instead of 2-dimensional. So when you will watch a 3D movie, that's what it means. Width, height, depth. All right. So just like the shapes, they come with geometric versus organic. So mathematical versus freeform sort of thing. And we have an additional qualifier, open versus closed. Okay. So geometric forms math. It's all about math and names. If it has a name, if it's easily identifiable, if it follows a set of rules, if it has math equations, it is a geometric form. If it does not, it doesn't. Here's an example of some mostly geometric forms. This is a cardboard sculpture that I found. It's really cool looking. It doesn't have a name. I'm sorry. I don't know who made it. If they ever find it, please let me know so I can credit properly. And then QB9, which is interesting because honestly, there's like 10 of them. It's a cool looking sculpture because it makes all these pieces look like they float. They're not really floating. They're all welded together, but it's clean. So it looks like this one's going to fall in a minute. But these are all geometrically derived. Organic forms, remember the banana joke, doesn't necessarily mean it's edible. We're not in science class. We're not in agriculture. We're in art. In organic, it just means it's not mathematical. So it doesn't have equations. You are an organic form. I am an organic form. The chairs you're sitting on are organic forms. We could technically argue because they're plastic. They come from dead dinosaurs. So we could get away with that. But not all chairs are made of plastic. So here are some examples of some organic forms. We have Blueberry Pie 1 by Clay Oldenburg. He likes big food. And then we have an untitled piece by Ellen Jewett. This is really cool. It's a little bit funky because the way the limbs are drawn and stuff like that is obviously high fantasy. It is not supposed to be really realistic, but it's really cool. Open forms, guys, this is really basic. Open forms have holes. They have negative space. They have emptiness. They have gaps in between. Okay, so hope right here. Look at all these little holes in hope, which now that I think about it, it's kind of interesting. This is an example. This is a bunch of different student works. They're cast out of what appears to be concrete or plaster. They could be plaster. But look at how cool they are fitting together. None of them are identical. They follow certain rules, but not necessarily applied the same way. Like there is a round shape in all of them. There's a round cutout in all of them. Okay, but they're all different and they look really cool put together. Closed forms, no holes, no gaps, no spaces in between, solid form. So here are 2 examples of solid forms. This is Kenya by Philippe Farreau. Absolutely gorgeous sculpture. I love his work. Look at the textures. Like her skin has absolutely amazing texture on it. Those shells, you know exactly what those shells look like. You know exactly what all of these parts and pieces look like in reality. Very incredible piece. This is Il Cavallo by Da Vinci. Now, the interesting part of Il Cavallo is Da Vinci actually died before it was finished. And in recent years, a whole bunch of art students came together, collected all of his sketches, all of his plannings, all of his diagrams, and the pieces that he had made, gathered up the remaining materials, and finished the work based on his design. So the fun question is, who's the artist here? Da Vinci or the students? Da Vinci's the artist because Da Vinci has the idea. In this capacity, all of the art students that put it together were acting as craftsmen because they were operating not on their own idea, but on the idea of somebody else. So it doesn't make them less of artists, but in this case, they were not the originators. All right, so we're gonna play a game and I'm gonna pause a bunch and y'all are gonna answer the questions. I'm going to ask for volunteers, or I'm gonna volunteer you, and you're gonna answer these series of questions. So about each image that's up here, you are going to tell me whether or not it's a shape or a form. I'm going to start there. If you think it's a shape, you're going to answer me whether or not you think it's geometric or organic. And if you think it's a form, you're going to say geometric or organic and open versus closed. So let's talk about this piece here. What is it? Moving on. It is a closed geometric form. Geometric because it is a mathematical, it is a pyramid. It has a name. It has math equations. It's a form, even though it's represented in a two-dimensional plane, we are indicating that there is a third dimension, that there is a separate piece indicating depth behind it. And it's closed because there's no holes. What is this one? This is a geometric shape. In fact, most of you should recognize it. If you don't, you need to practice before you get behind the wheel of a car. This is an octagon. This is a mathematical shape. What is this one? So unless there's a little worm involved, this is an organic form that is closed. Okay, so we assume that it is filled in. Once again, unless it's got something in there, but it is a closed organic form. What's this? This is a free-form organic shape. It is flat. There is nothing on here indicating that there's a third dimension. If it were shaded, it would be representing something that was 3D, but right now, it's not. This is flat. This one is Trixie. Pay very close attention and we'll talk about it. This is an open organic form. Now, most of you, many of you probably are thinking that this is geometric. And the reason for that is because it's got this perfect little rectangular side and you know it's a width. So you're being tricked into thinking that it is mathematical. But this is not a mathematical shape. This is the letter B. Letter B is organic. There is no way to easily determine the height, the width, the area of that. You have to have complex mathematical equations to determine that. Additionally, does every B in the universe look the same? No. All y'all have to do is compare your handwriting to figure that one out. Okay, so this is considered organic. If any part of a form is not mathematical, the entire form is considered organic. Okay, so even though we have this beautiful geometric rectangle hanging out over here on the side, because this is an organic shape, the whole form is considered organic.
Good morning, everyone, and happy Wednesday. Futuristic Falcons will be meeting with.
I apologize for that brief gap. I'll try to cut it out later, but it might take me a bit. All right, so at this point, now we're just going to look at pretties. Pretties! All right, so we have Temple Gardens by Paul Klee. If you guys remember, we talked about Paul Klee's Fire in the Evening, where it was mostly blue boxes, blues and purples, and then there's one red box in there. And then we had the one person that looked like he got stung by a bee. And then Beasts of the Sea, La Bête et la Mer, is Matisse. This is actually a collage. So it's like cut paper pieces all put together. It looks really cool. Do any of these actually look like sea animals that you recognize? Probably not, but there are characteristics of these organic shapes that remind us of sea life. Doesn't necessarily have to represent. More Things by Mary Blair. Now, Mary Blair was really interesting. If you look at these images, those of you who've been to Disney should recognize something.
Good morning, Falcons. This is Joseph.
Morning announcements. Anyways, if you look at all these shapes by Mary Blair, it should look familiar. For those of you who've been to Disney World, you might have a song in your head right now, because Mary Blair was the concept artist behind It's a Small World After All, which is what these are related to. These are some really cool pieces. I have a piece here in just a minute I'm gonna have to apologize for because I have to find out who it was by. Not sure who designed this. It's a very interesting structure. It just looks neat to look at. This is Great Still Life on a Pedestal by Picasso. Once again, titles. And I'm sure y'all are looking at it going, that doesn't look like a still life. Well, you have to look a little bit closer and understand that it's mostly discombobulated. So it's kind of warped and funky. This is definitely a pitcher. Pitchers that hold water. So we have this beautiful pitcher here. We have a table. It's one of those clawfoot tables where the legs kind of have like little feet on them. Picasso apparently wanted them to dance. And then, you know, a little pedestal with a fruit cup and things like that. So it's a lot of weird things going on in here, but they are interesting. Very, very cool shapes. This is not Great Still Life on a Pedestal by Picasso. This is an example of Miss Bergman not remembering to change and fix things. But these are really cool. These are big, giant animal sculptures made out of rolled newspapers, okay? They are life-size. They are amazing. Look at how realistic this is. And all they did was just roll up sheets of paper. This is actually fabric art. So each one of these are tiny little pillows. Paper cuts. So this is just cut up paper, various shapes, some of them incredibly organic, some of them way more geometrical, but still representing organic things. Now, there's not really a whole lot of actually geometric shapes. They just have that quality because of the specific lines and clear arches. This is Broadway Boogie Woogie by Mondrian. And if you look at this for a little bit, maybe you'll figure out what this is actually representing. Maybe. We have Spring Turning by Grant Wood, corrugated art made out of cardboard by Mark Langan, and a Nigerian funerary cloth. Look at all of the different shapes that are being represented here. Lots of things. Incredibly interesting to look at, despite the simplicity of each of these. Geometric Mouse, this is the same dude that did the giant blueberry pie. And then Cycle by M.C. Escher. Used to be that you could not walk in a middle school math teacher's classroom and not have a poster of Tessellations by M.C. Escher. That's not as common anymore. Kind of breaks my heart. But they're really cool because they're shapes that interlock together. And Escher liked to play with these shapes to make them not just interlock together, but evolve. So the shapes would change into other things. It's really neat to look at. And then this piece is by Andy Goldsworthy. Now, if you remind me, I'll show you some more stuff by him, but he was a site natural artist. So he would go on site, he'd go out in nature. Oh my gosh, I touched grass. And he would collect objects and arrange them. None of this is painted. The only thing that is probably not part of the natural, it would be this black panel here. I would say that's probably like a black piece of paper or something that he took on site. But he went and he gathered up all of these fall leaves, arranged them by color or sorted them by color, arranged them into this circle and took a photograph. And the thing about it is every piece of his artwork doesn't exist after he leaves site. He usually puts it back into nature, takes that photograph, gets that image of what he created, and then just lets it disappear. So very interesting to look at, though. On that note, ladies and gentlemen, see you later.